My daughter has showed me that circuits can be cute, and she gave me a lot of ideas. I have worked with thousands of children throughout the years. I'm a strong believer every kid should have some kind of understanding in coding. I believe no matter what they do in life, just like you need to know some math, you need to know a little bit of coding. And I'm especially interested in girls in STEM fields because I don't see enough girls in STEM fields, and I have 3 girls, so this gets me going. I took one of these home for the holidays to show the kids, and then my daughter, let me just take it apart and show you better. And then my daughter decided to take it and start adding these little thingies on it. She used the word, I can't remember what she used. And then she started adding these on the tree because she wanted to make it better looking. And I'm like, oh, this is interesting. So we can code circuits and we can also make fun circuits. And this happened to be like, fun shape for the holidays. But then I started thinking, why don't we step away from traditional boxy circuits that you would see most of the time and give circuits shape, make them more interesting. And then I thought of something else. And now we have circuits that are more interesting that you can code, just like traditional, square, bulky, boring circuits. But those have shapes. They have more. Kids seem to, like when I took these home and I handed them to the kids, they are a lot more interested in now touching the circuit. They're not like, oh, this is daddy's bringing home another circuit. Now it's something more interesting that they want to code. I'm a strong believer in coding typed software. So you type code to do something. But then the focus here was very little children, and typing code might be a little bit hard. So the other option here is block coding. And with block coding, we've been doing Microsoft Make Code for many years. It's a fantastic tool. It works great. And we support it on some of our products. While looking at different options out there, I found this microblocks.fun website. And it seemed to be interesting. I like how I connected a microbit, and then without flashing the board, I add the blocks and then they just run on the board. And then I unplug the board and they still run. So there's a mechanism for the program to go right onto the circuit. And then the software will still continue to be on there, but then it's live. Like everything I do, I see in the circuit. I looked more into it. I went on the About Us page, started learning about like what is that, who made it. It's not built by corporate. Several very smart people who got together and decided to collectively work on this. One of them is actually a co-founder of Scratch, if you know what Scratch is, which is another fantastic tool, but there's no physical computing element to it. So it looks like he got some ideas from Scratch, from Microbit, from everywhere, and they're building this thing that is made by educators for educators. And I really enjoyed what I've seen. I got a hold of the team, I talked to them, we did a meeting, and I really enjoyed their passion and how much love they are pouring into the product. So this could be a very strong candidate that we are seriously looking into for Duolink and for programming these circuits, among other options, of course. I want to get into details into the making of this robot, John Doe, like John Doe, but that will be in a separate video. Till next time, bye-bye.